Hello, we are discussing about GATE 2015 ECE paper. A lead compensator network includes a parallel combination of R and C in the feed forward path. If the transfer function of compensator is s plus 2 by s plus 4, the value of RC is, we are going to calculate the product of R and C, that is also called as time constant. For a lead compensator whose transfer function is given as s plus 2 by s plus 4. So first we will see the lead compensator circuit diagram, which is realized with resistances and capacitances, that is electrical realization of lead compensator. So this will be looks like this. This is what electrical realization of lead compensator, and this is R1, C1, and you can write it as C itself, because there is no other capacitor, and it is R2. Output is this one and input is Vin. So transfer function of this one is output by input realization, output by input in Laplace domain. So V naught of S divided by Vi of S is nothing but transfer function. Transfer function is ratio of output by input in Laplace domain, that is S domain. So you can write it as this R1 and C are in parallel, so we can write it as a parallel combination. So make it as Z. Z is nothing but R1 parallel C. C we can write it as XC, reactance of capacitor. So R2 divided by R2 plus Z, where Z is equal to R1 parallel XC. So R1 parallel XC, XC is 1 by j omega C. You will get it as R1 into 1 by j omega C divided by R1 plus 1 by j omega C. So Z will be equal to R1 by 1 plus j omega R1 C. So this you can write it as R1 divided by 1 plus S means j omega S1 C. You can write in this way in S domain. So simply X is 1 by SC you can write directly. So then you will arrive at Z is equal to this value. Now you write at the transfer function. Transfer function R2 divided by R2 plus R1 divided by 1 plus SR1C. And if you are going to simplify this one, finally you will get this as V naught of S divided by Vi of S. Directly you can use this equation. It's a standard equation for the lead compensator, transfer function of lead compensator, which you can write it as alpha times of 1 plus SR1C1 divided by 1 plus SR1C1 times of alpha. So this is the general transfer function of lead compensator, where alpha is equal to R2 by R1 plus R2. So if you observe, now we are going to compare this one with the given transfer function, which is s plus 2 by s plus 4. This must be equal to s plus 2 by s plus 4. So now I am writing it as, if you are taking 2 common, then it will become 1 plus s by 2, and if you take this one 4 common, then it is treated as 1 plus s by 4. So 2 by 4 it will become 1 by 2. So 1 by 2 into 1 plus s by 2 into 1 plus s by 4. This 1 plus s by 4 can be written as 1 by 2 times of 1 plus s by 2 divided by 1 plus s into 1 by 2 into 1 by 2, 1 by 4. So now if you observe, this is exactly equal to this function alpha times of 1 plus SR1C1. R1C1 is equal to, now R1C1 is equal to 1 by 2 and alpha is equal to 1 by 2. So we can get these values from this expression as alpha is equal to 1 by 2. This is alpha into 1 plus S R1 C1. So S is there. Instead of R1 C1, what you are getting is 1 by 2. So R1 C1, product of R and C is going to be 1 by 2. So the value of R and C is 1 by 2, which is nothing but 0.5 is the right answer for this question. So it doesn't take much time. Directly you can use a transfer function, okay, which is a standard transfer function of a lead network. And you are going to compare this transfer function with the given transfer function. You can identify the alpha value and RC value. Thank you.